Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a concept of cavitation, effects of cavitation, and the precaution against the cavitation. So first we'll discuss about the cavitation concept, then we'll discuss about the effects, and finally we'll discuss the precautions. So in the cavitation, this is very simple concept, but we need to understand. So cavitation actually it is the phenomena in which the vapor bubbles will be formed. Okay, it is the phenomena in which the vapor bubbles will be formed. Vapor bubbles will be formed where? Vapor bubbles will be formed in the liquid. Okay, and when it will be formed? When the liquid will, when the pressure of the liquid falls, when the pressure of the liquid will falls below than the vapor pressure will fall below the vapor pressure. Okay. Then vapor bubbles will be formed in the liquid. And after formation of vapor bubbles in the liquid, like see here pressure falls. So when the low pressure fluid will be moved to the higher pressure, so in that condition, that vapor bubbles which was formed, that is going to collapse. So vapor bubble like vapor pressure which falls this one. Now when it will move to the higher pressure, the next step is when the fluid will move to the higher pressure. Then this vapor bubbles which was formed, that is going to be collapsed. So collapsed of the vapor bubbles, and that is called actually. So when the vapor bubbles will be collapsed, so the cavitation will be formed in the metal. That cavitation will be formed in the pipe, or you can say in the materials. So let me form the same thing, like where you are writing with a vapor, you can write the same what. Now, so to understand this cavitation concept, as I told you, this is the definition of the cavitation, but to understand in more details, we need to go back to our previous lecture where we have discussed about the Bernoulli's equation and we have discussed about the working principle of venturimeter. Okay, so along with that also we have discussed one more terminology, that is vapor pressure. I told you here vapor pressure. So three terms are important here, as I have mentioned here. The first one I can say, one is, this is our first point. First point what? That is vapor pressure. Suppose the first point we need to we should have some idea about vapor pressure. What is vapor pressure? Okay, and the second one is the venturimeter. Okay, second one is the venturimeter, and the third one is the Bernoulli's equation. So these things already we have discussed previously. Just I am giving a recap to this one to understand the cavitations. Okay, these are the points we need. We should have some idea. So first, what is vapor pressure? So vapor pressure is nothing but this is the pressure which is exerted by the vapor, which is exerted by the vapor. Okay, which is exerted by the vapor on the liquid, by the vapor in the thermodynamic equilibrium condition. Okay, that pressure which is pressure, we can write here, this is the pressure exerted by the vapor in a thermodynamic equilibrium. That means we need to maintain that as a thermodynamical conditions. Okay, with the condensed form. Okay, with the condensed form, that means it may be liquid or it may be a solid form or maybe other forms will be there. Okay, and that should be, and this vapor pressure will be, this concept will be applicable only in the closed system. Only it will be applicable in the closed system. Okay, and at a specified, at a given temperature we need to do it. At a specified temperature we need to do it. That is vapor pressure. Venturimeter was what? Venturimeter actually, this is the device. This is a device which is used, okay, which is used to measure the rate of flow or flow rate, we can say, or discharge, we can say. which is measured to use the rate of flow. Okay, and the last one, that is Bernoulli's equation. Bernoulli's equation, this is the concept which was given by Bernoulli. Okay, where the energy, okay, it's talk about the energy which are involved in the fluid flow, that should be equal in all the places. Okay, energy, we can say energy equilibrium in a fluid flow, energy equilibrium in a fluid flow. Okay, now we'll try to understand how this cavitation formed by this. So as I told you that we need to understand these concepts: vapor pressure, venturimeter, and Bernoulli's equation. So now let me suppose consider a pipe, okay, which structure is like a, it's like a venturimeter. Okay, so the venturimeter, how it is, we know that this is our venturimeter structure. It will be like pipe will be there, then convergence, then throat part, and then divergence part. Again, pipe formations. Similarly, this is the lower portion of the pipe, convergence, again throat part, okay, then again divergence, again pipe is there. So here, let's suppose the water or the some fluid is flowing through this venturimeter. Okay, so now we can see this is the venturimeter. So how to measure the rate of flow? We can connect, okay, some manometer here, and by that we can measure the pressure, and what is the quantity of fluid we can find out from here. Okay, so this is the measuring device. It is having different structures also there. Now, what this is about venturimeter, as I told you. Now the next concept is Bernoulli's equation is going to applicable on this device. Okay, so Bernoulli's equation, suppose if you consider this is a section 1, at the section 1 how much energy is there. Okay, at the section 2 we should have the same energy. Okay, energy means what, which kind of energy is involved here? Already we have studied that the total energy, that Bernoulli's equation what is given, that is we have the potential energy, and okay, potential energy, then we have like pressure energy, and the kinetic energy. Okay, all this energy, kinetic energy, all these three energy at this first location or the first point, how much should be there? It should be same at the second point also. Okay, now potential energy means that is the potential head, we can say that how much height is there from the baseline or from the reference line. We can consider here, suppose a reference line is there or datum line. Okay, from this point how much height is this pressure. And the next is pressure energy. So pressure energy in this point we can take what is the pressure is there. Okay, how much pressure is there, and what is the pressure head. Okay, actually this is potential head, pressure head, and kinetic head, both will be, that should be equal to constant, that should be there, but I have written in the form of energy so that we can understand what is the pressure value at this point and what is the kinetic energy, in the sense how much velocity is there. So at this point what will be the pressure here, okay, and what will be the velocity. Similarly at this point what is the pressure is there, P2 and P2, this is P1, P1. Now if you see, another concept is there, that is continuity equation, A1 V1 equal to A2 V2. Okay, so before that concept, let me first tell you about this one. Now see, here area is more, another concept, as I told you, that is continuity equation. So continuity equation what, that is A1 V1 equal to A2 V2, or else we can write AV equal to constant, some value is there. Now here what it indicates, if your area is more, if your area is going to more, then velocity is going to, velocity will be less. If your area is less, then velocity is more. That is one concept here. Now from this Bernoulli's equation, what I can say, like suppose your area is, now at this point our area is more, here at this point, but if you come to the second one, the second section. At this section, our area is very less. Now section 1, if I consider at this point, let me change this color. At this point, our area is more. Okay. So at this point, what will be the velocity? Velocity will be less and pressure will be more. Okay. At section 2, our area is less. Okay. And velocity is more, but pressure will be less. So in the Bernoulli's equation, if you have remembered, okay, the formula is like P by rho g, and this is V square by 2g plus Z1, or Z equal to constant. This is our equation. So if you want to write here P1 V1 square, then this is also like you can write Z1. This is equal to P2 by rho g plus V2 square by 2g plus Z2. That is the concept. So what is this means? This is our pressure energy, or pressure head actually. This is our velocity head. This is our potential head. Correct? Now here, as I told you, this equation is very simple. Now as I told you that area increased, velocity decreased, pressure increased. So at this point we have more pressure. Now suddenly the pressure is going to change. Pressure is going to change because of the area here. Like means how much area, very less area is there. Velocity will be increased. So here velocity will be increased, then pressure will be decreased here. From this equation we can understand. Now though the pressure pressure here decreased, so our properties of the fluid also is vary on the pressure. So we can write the properties of liquid. So properties of liquid in the sense that the fluid which is flowing here, suppose here water. Properties of water, if you see, we know that the boiling temperature or boiling temperature of the water is at 100 degrees centigrade. So 100 degrees centigrade means at 1 bar pressure. So here pressure is 1 bar. Now if I reduce the 1 bar pressure, or if I suppose increase the 1 bar pressure to 2 bar, then the boiling pressure, the boiling temperature, maybe it will increase up to 130 or 150. Some temperature will be increased here. Then at that condition, our boiling point or boiling temperature of water will be not at the 100 degrees centigrade. Similarly, if I reduce the pressure value here, suppose 0.5 bar. If I reduce the pressure of 1 bar to 0.5 bar, that means it is 1 bar we have taken. Why? Because it is P atmospheric pressure is there. Now suppose our pressure is reduced by some regions, then obviously this temperature also will be reduced. So the temperature at this point, like 50 degrees centigrade, we can boil the the water will be started boiling. Okay, so at this point, if you are able to like reduce its pressure, then at this low temperature also the water started boiling. Okay, that means water bubbles will be started. Okay, bubbles will be started because of the boiling here. Now how, as I told you that here already pressure is reduced at the second point, like the second section. Now by this, if suppose the pressure reduced to suppose 0.3 bar, and the temperature like at this 0.3 bar, the water can be like started boiling. Okay, here suppose it is 40 degrees centigrade or 30 degrees centigrade. At this temperature also the water can start boiling at this pressure. Okay, so now as it is decreased, the pressure decreased, the here bubble formation started here. Okay, where at this point you can see some kind of bubbles will be formed like this. Okay, bubbles will be formed in the water itself at this pressure. Now again, when it is in divergence mode, now second, now if you consider again another one, that is third. So the third position, if you see the third section, again same thing, like it is equal to the section 1. At this section 1, what was the same thing at the section 1. At this point, what our area increased, here velocity is going to decrease, but pressure is going to again increase here. So here we have low pressure, here we have low pressure, at this point we have high pressure. So when these bubbles will be formed, like when already bubble formed here, so when the bubbles will be moved from here to these, okay, now at this high pressure, this pressure will be like the bubbles will be started blasting. Okay, the bubbles will be started blasting there. I told you already it's going to be collapsed here. So due to this collapse of this bubble from these bubbles, they will release a pressure. Okay, and that pressure will be give impact on the surface of this pipe. Okay, when the bubbles is going to be collapsed, that bubbles will be formed, like, you know, it will release a pressure, very small pressure is there. Okay, inside the bubbles very small pressure will be there, but the small pressure will give an impact on the surface of this. Okay, and here that the surface is going to started rough. That means some cavitations are formed in the surface of material, and that is called cavitation. Okay, that is called cavitation. So I hope you understand from this concept what is cavitation. Definition already told you that this is the concept in which the vapor bubbles formed, and when the vapor bubble formed, when the pressure falls, which pressure? The atmospheric pressure fall, or you can say the local pressure of this liquid when it falls less than the vapor pressure. Okay, and again when the vapor pressure of liquid will be moved to the higher pressure at this point, then here already our vapor bubbles already formed here at this point. So with the same vapor bubble, when it will move to the higher pressure, that will start collapsing, and due to that vapor bubbles will release a pressure on the surface of this, and that will make a cavitation. Okay, so this is all about the cavitations. Okay, now we'll see what will be the effect. The second concept is effects of cavitation. Okay, so in the effects of cavitation, I'll just mention some points here. Okay, I'll just mark some points here. What will be the problem, or what will be the effects due to this cavitations? Okay, so this surface, first thing is damage will be there. Okay, what damage? The surface will be damaged of the surface of the pipe will be damaged here. So here I can write a point like physical damage. Okay, there will be a physical damage. So physical damage in the sense what? The surface of pipe. Surface of pipe will be damaged here. Okay, the second point I can write, that is performance. So performance will go to the next one. See, due to this bubble creations and its collapse, okay, there will be some noise, sound will be there. Okay, there is some noise or vibration will be there. So due to this sudden collapse, okay, due to the sudden collapse, there will be noise will be formed, and along with that also vibrations also will be there. Okay, sometimes you have maybe seen in the pipe there will be sound, tuck 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 sound will be there. Okay, when the when you open the pipe, or when you release the valve, there is some vibration and sounds will be there. Okay, so that is one point. Now the next one is, that is about the performance. So in the performance means how the this turbines or pumps it's performing. It talks about the hydraulic machines. So the performance about the hydraulic machines, how it can. Okay, so by this, like performance, how it will be reduced? So efficiency is going to decrease. Efficiency is going to decrease. Okay, because when you don't have any kind of like more discharge will be there, because here pressure difference are coming and collapses are happening about the bubbles. So that will also restrict the fluid flow. So by that, your efficiency is going to decrease. Okay, and another one point I'll just add it here, that is about the loss. The loss of what? The loss of machine life. What about the life of the machine? Okay, so machine life we can write, or longevity of the machine product. So see, to increase the machine life, we need some kind of maintenance regularity. But if this kind of formations will be there, pressure difference will be there, then obviously the machine life is going to reduced. Reduction of machine life. Okay, and this performance already I told, like efficiency is going to decrease because our discharge is going to decrease, and that here we can see the pressure, though the pressure is as a point, there also that will be effect in the performance also. Okay, because all these things are related to each other, and machine life also decreases. So these are the effects of this cavitation. Okay, now the last one, as I told you, we'll discuss about the precautions. So how we can avoid this, or what are the precautions can be taken, okay, to avoid the cavitations. So to avoid the cavitations, actually, already I told you that one point already informed you that we need to do regular maintenance. Okay, we need to do regular maintenance. That is the first and foremost, regular maintenance of pump or any kind of hydraulic machines, we can say. So why this regular maintenance is required? To maintain the pressure level, to check the pressure level whether it is exact or proper or not. Then we need to follow the proper design of the machine. Okay, we need to follow the proper design. Then also we need to check it, or we need to follow the proper operating conditions. Okay, how it is operating, or who is operating that machine, whether that operator is skilled or not. So proper operating conditions. So all these things you need to check. And one more point is there, that is NPSS. The NPSS is available or not, that means that the net positive suction head, that we'll discuss in our next lecture. So this is all about the cavitation and its effect and its precautions. And one more thing that you can think, that where this precaution will be affected, or where it can gives more importance, or it where it can be created. Okay, so the cavitation will be mostly formed in the hydraulic machines. Hydraulic machine means pump and turbine. So it basically occurs in the centrifugal pump. Okay, it basically occurs in the centrifugal pump. Which centrifugal pump, which point or which place, the position, that is, if you remember, that impeller, already we have discussed many number of times in our previous lecture, impeller is there. So at the impeller eye, there will be a cavitation formations will be there in the centrifugal pump. Another one is there, Francis turbine. Previously we already discussed about the Francis turbine. Okay, Pelton turbine, there will be no cavitation issue is there. Only Francis turbine will have a issue about the cavitation. Along with that also we'll have a issue in the propeller turbine. We'll have the issue in the propeller turbine. And mostly if we have more bend in the pipe, or you can say any kind of valves will be there, more bend in the pipe and valves will be there, then there also will have this cavitation issues. So these are the basic parameters or basic fundamental informations regarding the cavitations. And also I'll tell you that it's specially when it will formed or when it will occurred, basically the difference of pressure. Okay, vapor pressure, when it is when the local pressure or when the atmosphere pressure is reduced or less than the vapor pressure, this forms. Even when our fluid is flowing with a high speed, okay, when the fluid is flowing with a very high speed, there is a chance of cavitation formations also. Again, even that low suction pressure will be there, and the pressure is low suction pressure, there also there is a chance is there, and the high temperature of liquid. So at this, all these issues are there, there is a chances of like cavitation forms. I hope you understand this lecture. If you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.